Hello, Lily and Stefan. This is Vance. I'm here to take a look at the items that we need to address, and I'll go over them one at a time. When we printed out the parts, we were missing the weep holes and missing the drain design on one side. Now, I know that we had redone that, or you had done that drain hole redesign. Maybe I'm using an older file. I'm having Carl check, but if you remember, we have this drain design and it was supposed to be mirrored on this side with weep holes. So the parts that I had printed out from him did not have this weep holes here on this part of it, the back part of it, and it did not have the rest of the drain design here. So I'm hoping that we just had an older version, and so that means that number 1 and number 2 are already taken care of. So I'm almost positive that we had added these design changes to this other part already. You've already done that and added the weep holes. So I will confirm that, and hopefully you can. The third thing here is that the counterweight arm is too weak. You can see here that I've broken it off just by having it in a container. It just snapped right off. So this gusset is good. I think we need another gusset on the bottom. It's also broke off of our design too, and we even have a stronger part there with a bigger gusset, and it still broke there. Harder to break it, but so we need to strengthen that joint with a gusset or something to make the counter arm a little bit stronger, especially since I'm not sure if polypropylene is stronger than ABS or more brittle or weaker. I still think we'd need to have a little bit stronger part there. The bottom of the slide, this was also something that we closed off in the design. I know I've seen that you've done it, but the printed part and also on the bid, I noticed that part was not closed off. So we just want to make sure that when we get those final files to do the actual CNC, that this part is closed off. Okay. And that brings us to another issue, and that is that this new slide is much thinner than the existing old slide. And you'll see that there's a reason that we need to make the new slide the same width as the old slide, because we are making a bracket to hold it, and that bracket is all based on that thickness. Okay, more about the bracket later, but we need to ensure that this slide has a bar across the bottom so the nut won't fall out. You won't accidentally pull it all the way through, but also it's going to be the same width as the old part, not this thinner new part. Okay. Number 6, we need to ensure easy rotation, and this is hard to verify this is the 3D printed version of your parts. As you can see, it holds up. Now that could quite likely be from the 3D printed. It has a little bit of a different resolution than the actual parts, but we want to make sure that those parts rotate freely like this, that they come right back down. In fact, it's nice to have just a little bit of slop in there, and the reason is when that comes up and it can move as it cleans, it kind of vibrates back and forth like that, and it actually helps it clean. So a good smooth surface and a smooth, easy operation with just a little bit of give in it like that is good. We don't want to have it too tight of a tolerance where it just is perfectly smooth, because that little bit of give actually helps it clean side to side, back and forth. As it's spinning, it tends to go back and forth and clean better if there's just a little bit of give. Okay, so that's an important note. Okay, and then this final part here is we need help with the bracket design. What we're going to do is the part that you've already designed is going to be slightly modified, as you can see here, to have a hole through it and a nut capture portion. And you'll see what the purpose of that is. We've made this part for our bracket. Normally, our unit would just strap to a bullet style camera. It would strap right on. So this would be the only part that we need. Okay, that would strap onto the camera, and that's how we do it. There are times when it would be nice to strap this part onto the camera and then screw this so that we have rotational ability through that hole, and with nuts inside of there, we can now have this part strapped to the camera, and then we can adjust this side to side and tighten it up. So we can adjust it side to side. So this part would serve that purpose, and it would allow the new part to work in conjunction with it by screwing to it and being able to be adjusted. In addition, this part is designed to have screws go through it, so it can now screw to the wall or to the ceiling, and then that allows us to attach our bracket. So here it is, the way it's designed. This is screwed solidly to the wall or ceiling with 4 screws. Then this part can bolt to it. What that does is this allows us to have infinitely adjustable, not infinitely, but pretty much infinitely adjustable. We can go side to side, up or down. It can even turn this direction, except I've got it very tight. And this direction, so that on the other end, we can hang our unit. Here's one with only one slide on it. So if you want to hang it, for instance, on the side of the building and only have one slide, now it can operate. So the benefit of this bracket design, I'm trying to accomplish it with as least number of parts as possible. So this part would be our same part, just modified. It gets used on each end. So it gets screwed on the wall end of the bracket is the way we connect it, is with this part. And then we connect the actual unit with a screw on this end, and that's how we connect the unit. This design has a groove in it, and we will send you the files to show you this groove and this part. But these two parts are the same, and these two parts are the same, and this part would match if we needed the same part on this end if it was a different orientation. Or this. It allows many different orientations of the same thing. And so this allows us to attach to a ceiling like such and adjust the unit out here to be in front of a box or a dome camera. And it also allows it to be attached to a wall and to allow it to adjust to a camera. And these slide like such, so we can adjust the length up and down, back and forth, almost like a scissor. So there's all kinds of adjustability here. And then once you get it into the position that you like, you can tighten this down very well. And because there's a groove in this side, these nuts lock in, and it works extremely well to hold the product. So we're going to want to injection mold this bracket also as part of this project. So I'll be sending you files of that. Now, if there's some improvements to the method of making a bracket like this, or if you have pre-made brackets that you think would work better and give all of this adjustability, that would be great. But if you can imagine a camera attached to the ceiling, this has to reach up and be able to essentially put our product around it and to the other side of it. If this camera was attached to a wall, this has to be able to attach to a wall and bring our product out in front of it in whatever distance and direction we need it to. So I think you can see that this bracket has been a real difficult project to get it to be something that can be totally adjustable, to bring this unit, as you can see here, to bring that unit directly to where it needs to be held underneath the camera so that it comes up and cleans properly. Okay, so those are the bracket parts we need to make. I'll send you files for this one, the modified part, the two slide parts, and then two of these and two of these per bracket. Brackets will only be sold on about 50% of the product, so we will need less brackets than we need products. Now I have a question regarding the strength of the polypropylene versus the ABS. When we have screwed a screw into this hole, when we're attaching it to these blocks, we've had the screw pull through there and damage it, so that's why this is made thicker to work on that. I hope that this video clarifies what it is we're looking at and the issues that I'm dealing with and why this needs to be thicker back to the original thickness, and why we need to address a couple of these. Now, I was not able to, because of the printing, you can see here, we were not able to get this to screw on to this unit, probably because of the 3D printing has a little bit different tolerances than everything else. So we actually had to, this broke just getting it to try to screw on to this part. Likewise, 3D printing the propeller didn't work out. So that's why we need to do the CNC version. And so before we move forward with doing the CNC, I'm not able to test the propeller. Unfortunately, I wished I could have tested the propeller too before we move forward with the CNC. But we need to address these 7 issues so that we can move on with the CNC. I think that these 2 have already been addressed, 1 and 2. And I think 4 has been addressed. So I think 3 of these have already been addressed. We just need to beef up the counter arm, bring the slide back to its increased thickness, and ensure that we have easy rotation. And then we need to deal with the design of this bracket, perhaps separately, but because this part is part of our existing design, we need to be aware of the bracket design and how it's going to come into play with the rest of the product, and anticipate that we're going to have more molds and injection parts being made. If you have any questions, I know this has taken me a long time to get all this to you, but as you can see, we've been very busy on this end testing and breaking. We've broken these things these things break pretty easily, so we had to make modifications to them and make them much stronger so they can't be broken in any way. So we've been testing the heck out of these and redesigning these parts to make sure that they are stronger, more durable, and will work. Very much looking forward to getting this information to you and moving forward. Thanks so much.